Hi, welcome back. Okay, so we are going to be going over chapter 1 test review. This is all about lines, planes, segment addition postulate, and weighted averages and partitioning a segment. So for question 1, this is our image that we're using. We have 3 different things. It says, and identify the intersection of line IJ and line DF. So if I'm looking at line IJ, that goes from here to here, and then DF goes from here to here. So where they're actually crossing at is point G. So I'll write point G because they're intersecting, they're crossing at that point. The next one is identify a point that's not on the plane. So remember, your plane is like your flat surface. Think about it as the top of your desk. So all of these, point H, line DF is on top of the plane. IJ is actually going through the plane. That's why it's a dashed line right here. So we're looking for a point not on our flat surface. So the only point that's not on our flat surface technically is point K. So we're going to put point K. Point J is technically not on our surface either, so you could use that if you wanted to, but since that's part of this line right here, I'm just going to say K because it's a point by itself, not on the plane. Identify 2 collinear points. Collinear means that they are 2 points that fall on the same line. So there's a couple different answers that you could use here. As long as they are 2 points that fall on the same line, you could use them. So for instance, if I say DF, both of those are individual points. Point D, point F, they fall on the same line. I could also say D and G. I guess I should use like an and symbol. D and G. 2 other points that also fall on the same line are G and F. Any of these would be possible answers. Now, if you look at the other line in the picture, we have this one. We have 3 different options that we could say for this line. We could say IG, because they fall on the same line. We could say GJ. So G and J, they fall on the same line. We could also use I and J. I and J fall on the same line. They're collinear. We can't use H, we can't use K because they're not on lines. I would not be able to say I and F. I and F do not fall on the same line. So you don't have to list all of them, but you do have to list one of these options to have your answer correct. So moving on to question 2. Question 2 says 3 pins are inserted into a cork mat at points C, E, and D. The 3 pins are collinear. They fall on the same line. How much string is needed to reach from the pin at D to the pin at C, then go back to point E, or the pin at point E? So I'm starting at D, I'm going to C. So if I could draw a line, starting at D, I'm going to C, and then I'm also going back to pin E. So I'm starting here, going to C, and then I'm ending back at E. So what we're doing is we're adding the entire length of the segment, and then we're also going to add in this little portion. So the way I can write this is 4.5 plus, because this is 4.5. I'm going all the way, so I'm going to add 1.3. And then I also, so that represents the entire length. I'm also going back. So I'm going another 1.3. So I'm going to add all of these together. So if I add 4.5 plus 1.3 plus 1.3, I end up getting 7.1 as my answer, because that's the total length from D to C, and then from C to E. Going to question 3. Question 3 says, use the following information to find X. Write the value of the variable. So I'm just looking for X, so I do not need to plug it back in. I'm going to draw a picture because anytime I'm not given a picture, you should draw a picture. It will help you. So if I draw a picture for this, I'll put it here. It says B is between A and C. So I'm not going to read all of this because it's going to confuse me. I'm going to take piece by piece. So B, I know, is between A and C, so I'll put A and C, so B is between them. I know AB, this portion from A to B, is equal to 6x plus 7. 6x plus 7. I also know BC from B to C is 18x minus 5. And I also know that AB is congruent to BC. Congruent means that they are equal to each other. So that's where I have this little line. That means they are equal to each other. So I'm going to have to solve this. I'm going to have to write an equation to solve this. So I'm going to take this piece and set it equal to this piece because I know they are congruent. So if I take 6x plus 7, I set it equal to 18x minus 5. Now I'm going to draw my line. And you can pick what to move first. I'm going to move the 7 to the other side of the equation. So I'm going to do the opposite of adding 7. I'm going to subtract 7 to both sides. 7 is a number, so it has to line up with the number on the other side. So if I cross them out, I bring down 6x equals 18x. Negative 5 minus 7 is negative 12. Now I'm going to move my 18x to the 6x. 18x is positive. So to move it across, I'm going to subtract 18. Because it is positive, I'm subtracting it. Positive 6, I'm sorry. Positive 6 minus 18 is negative 12x equals, I'm left with negative 12. Last step I need to do is divide on both sides. Negative 12 divided by negative 12 is 1, positive 1. So my answer, x equals, is 1. If it wanted a dimension, I would have to plug it back in, but that's not what I'm looking for. Okay, so question 4. Question 4 says, what is the length of AZ? Use the following information. So I know A is between Y and Z, so I'm going to put A here, Y and Z. It says YA from Y to A is 14, so I'm going to put 14. AZ is 5x. And I also know that from Y to Z is 109 in total. I have to write an equation for this. This is segment addition postulate. So I'm going to do 14 plus 5x equals the whole thing. So 14 plus 5x equals 109. Now I need to solve for x. So I have to move my 14 to the other side of my equation to get to the 109. Numbers must go with numbers. It's positive. So I'm going to subtract 14 to both sides. So I have 5x equals, and I'm going to do 109 minus 14 is 95. And then I'm going to divide by 5 to both sides. So x equals 19. Now I need to find the length of AZ. So I'm not done. The answer is not 19. I need to know AZ. AZ is this portion right here. AZ is equal to 5x. So I'm going to take 5 and I'm multiplying it by what I got for x, which is 19. 5 times 19 gives me 95. So AZ equals 95. I just realized there's an easier way to actually do this. If you know this whole dimension is 109, and this is 14, you could just take 14 away from 109 to make 95. They don't want the value of x, so it does not matter what x is. The answer is 95 either way, because 109 take away 14 is just 95. So either way is fine. For question 5, it says, use the number line to determine which two line segments are congruent. You're looking for two that are the same exact length in total. So if I look, I have AB, which represents 2, BC, which is 1, CD, which is 3. So I'm looking for something that's congruent. So you don't have to go just from A to B. I could also go from A to D. A to D is the longest, so nothing's going to be congruent with that. But if I look from A to C, and I look C to D, these pieces are congruent. There are a total of 3. 1, 2, 3, 1, 2, 3. So I would say AC is congruent to CD. So even if there's a point between them, it does not matter. You're just looking for something that is the same length. Okay, moving on to number 6. So number 6 is where we get into partitioning. This is where you are taking your first X value and you are adding it to the ratio as a fraction. And then you're subtracting the second X value from the first X value, or X2 minus X1. So in this case, I need to figure out what my coordinate points are first. So A, if I started 0, 0, I'm going to the left 4, so -4. And then I'm going down to -6. So -4, -6 is the first A. Point B is at 5, 6. It says find the coordinates of point C that are on AB such that it is a ratio from A to C to B is 2 to 3. So C is somewhere on here. I don't know where. I'm going to find it. I need a ratio of 2 to 3. So if I split that 1, 2, 1, 2, 3, there's a total of 5 pieces. So I'm going to rewrite this as a fraction. 2 to 3 is really 2 over 5 as my R. So I'm going to label this X1, Y1, X2, Y2. So I got to find my X value first. So I'm going to take X1, which is -4. I'm adding my ratio as a fraction, which is 2/5. And I'm multiplying by the second value, subtracting the first value. So I have 5 minus -4. If you are subtracting a negative, 5 minus -4, that's really going to make a plus sign. So this is -4 plus 2 divided by 5 is 0.4. In my parentheses, I have 9. 5 minus -4 is +9 because I'm adding them. 0.4 multiplied by 9 is 3.6. So I have -4 plus 3.6. So I get -0.4. That's my X value. Now I need to do the same process, but I'm going to use Y1 plus my ratio multiplied by Y2 minus Y1. So Y1 is -6. I'm adding my ratio as a fraction, 2/5. And then in parentheses, I'm doing Y2 minus Y1. 6 minus -6. So I have that same thing. I'm minusing a negative. If I'm minusing a negative, even if you do it in your calculator, 6 minus 6 makes 6 negative. That makes 12 because it's adding the 6's together. So I have -6 plus 0.4 multiplied by 12. Remember, you're getting 0.4 because a fraction is fancy division. So if you take 2 and divide by 5, you get 0.4. I'm taking 0.4 and I'm multiplying by 12. I get 4.8. And then I'm just going to add those together. So I get -1.2. So my partition point is technically at the coordinate -0.4, comma, -1.2. Okay, next question. Question 7 says, Nate wants to visit his friend Mac before going to the park. Nate's house is located at -6, 6, while the park is located at 4, 2. Find the location of Mac's house if it is halfway between Nate's house and the park. Halfway means it's equidistant, means that it is congruent pieces. So this is technically halfway is going to mean the midpoint between those two locations. So my midpoint formula is where I take my two X values. It doesn't matter what order. I divide by 2 and I do the same thing for the Y's. Add them, divide by 2. So I'm going to take my X values, which is -6 and +4. These are my X's. I'm going to add them together. -6 plus 4 divide by 2. I'll find X first. -6 plus 4 is -2. -2 divide by 2, because I still have that fraction, is equal to -1. So this is my X. I'm going to do the same thing for the Y. Y is 6 and 2. So I'm going to take 6, I'm going to add 2 and divide by 2. 6 plus 2 is 8. 8 divided by 2 is 4. So this is my X, this is my Y. I added the X's together, divided by 2, added the Y's together, divided by 2. So Mac's house is halfway, which is at -1, +4. Okay, question 8. What is the length of RS? So this is what I'm trying to find. When R is the midpoint. Midpoint means that these pieces are congruent. If it is in the middle, I can set them equal to each other. I don't know the whole distance. They're not giving me that for a reason. So I'm going to take 6x plus 18, and I'm setting it equal to 3, and then in parentheses, 9 minus x. So first thing I'm going to do is I'm going to get rid of my parentheses using the distribute property. So if I distribute into my parentheses, 3 times 9 gives me 27. 3 times negative x is negative 3x. Now you could pick what you want to move. I like to move the numbers first. So I'm going to move the 18 across this line. So I'm going to subtract it because it's positive, subtract it to both sides. What you do to one side, do the other side. 27 minus 18 gives me +9. Since I moved my numbers from the left to the right, I must move my x's from the right to the left. The opposite of -3 is +3, so I'm going to add 3x to both sides. 6x plus 3x is 9x. Bring down 9, and then to last step, I'm going to divide by 9 to both sides. So x equals 1, but I'm not done. 1 is one of the answers, but it wants to know the length of RS. RS is equal to 3 multiplied by 9 minus x. So I'm going to plug that in. So 3 and then 9 minus 1, because x is 1. I'm replacing that x. Oops, sorry. I'm replacing that x with 1. Now PEMDAS for life, so I'm going to subtract 3 times 8. Oh, there's an error. One of these is not the answer. 3 times 8 is not one of the answers. What the heck? 24. Okay, well, there's a typo. I'll fix that before I make copies of these. Okay, so 24 is the answer. Okay, question 9. Question 9 says, find the coordinate of point P that represents the weighted average of A and B, where A has a weight of 3 and B has a weight of 4. So I'm going to call this x of 1. Its location is at -3 on my graph. The weight that goes with point A is 3. Point B's location is at 2, and the weight for point B is 4. So the point should end up closer to B because it has a heavier weight. The formula for this that we wrote down was weight sub 1 multiplied by x sub 1 plus weight sub 2 multiplied by x sub 2 divided by the weights added together. So this is my formula from your notes that we should be using. So I'm taking weight sub 1, which is 3. Okay, 3. I'm multiplying by x sub 1, which is -3. I'm adding weight sub 2, which is 4, and I'm multiplying, I'm going to use parentheses, multiplying by its location, which is 2. And now I'm dividing by the weights added together. So 3 plus 4. 3 times -3 is -9. I'm adding 8. I'm dividing by 7. -9 plus 8 is -1. And I'm going to take -1 divided by 7. 1 divided by 7. So I get this crazy decimal. But a decimal is just a fraction. So if you look, you could write this whole decimal. But if you look at your options, -1/7 is one of the options. So the answer is A. Bye.